Hi, my name is Ehsan Arefi. I'm a Master of Science student in Electronics Engineering. The reason that I'm creating this video is to offer a solution by creating a device that, if made successfully, it will have the ability to correct nystagmus. Well, as far as we know, glasses and contact lenses cannot correct nystagmus. And up until now, that it's now 2019 and it will be 2020 soon, lots of efforts have been done to cure nystagmus, but unfortunately, medically, there is no cure for nystagmus. But we really don't have to just focus our studies on finding ways to cure it. We can also examine ways of finding solutions of correcting nystagmus, like creating specific devices. Now, this video that I'm uploading is offering a solution, is offering a device that I'm going to explain to correct nystagmus. Now, before I explain how the device works, I want to show you something. So please watch the video and be with me. Thank you very much. So in order to show you how this device works, I'm going to use a flashlight and a magnifying glass. A magnifying lens. Let's see how it works. Well, imagine this is the point of interest, and this is where we are currently looking at. When our eye makes a movement, and also imagine this is the focus point, okay? When our eye makes a movement, this is what happens. The movement could be in any direction. It could be either vertical, it could be horizontal, or it could be circular. What we're gonna do in order to actually make this point to stay on this object, because this is the point where we are looking at. We don't want the focus point to come here. This is where we are looking at. We want the focus to stay in this place all the time as long as we're looking at this object. So this is the solution that I'm offering. As you can see, if I move the light to the right, the focus point of the light is going to be moved to the left. How am I going to bring it back to its place, the place where I was looking at? If I move the lens, it will be brought back to the place that we're looking at. If I move the light to the left, the focus point is going to go to the right. Now, if I move the position of the magnifying glass, I can bring it back to its place. Again, if I move it to the right, I can bring it back to its place once more. If I move it to the left, I can bring it back to its place. If I move it even down, I can bring it back up this way. And if I move it down, yeah, as I said, I can bring it up. And if I move it up, I can bring it down. Bring it back to its place. For these types of nystagmuses that are vertical. So as we said, we have different types of nystagmuses: vertical, horizontal, and circular, whatever. So we can see in any direction the eye moves, by moving the lens, we can bring it back to its position. Watch again. We're removing this here. Move the lens. Move the focus. Move the lens again. Move the focus to the left. Move the lens and bring the focus back to its position. So, as you can see, the movement of the lens is going to compensate for the movement of the eye. In other words, the movement of the lens is going to neutralize the effect of the movement of the eye. As we talked about it, practically, whenever the eye moves, the focus point moves. So this is how the lens helps to keep the focus point in the same place. The point of interest here is an ant, which can be seen in the picture. Now please pay attention to the movement of the lens and the eye.
Alright, so as you might have noticed, wherever the eye moves, the lens follows it. But this following is instantaneous. In other words, there is no time delay between the movement of the lens and the movement of the eye. This is how the movement of the lens neutralizes the effect of the movement of the eye and compensates for the movement of the eye, and in other words, we can concentrate on the object that we're looking at.
Okay, so now that we know how we got some basic idea or general idea about how the device works, or in other words, how nystagmus could be corrected by moving a lens, with respect to the position of the eye, we really need to know how the movement of the lens is going to be controlled. In other words, how we can control the lens, whether it goes to the right, to the left, up and down, or circular, or whatever direction. We really need to control this. How we're going to do this? Well, we need two sensors. A sensor that determines the position of the eye, or in other words, it's going to get samples from the position of the eye in very, very small periods of time, probably milliseconds, microseconds, whatever it's required. I'm not sure about this. Okay, so now one of the sensors determines the position of the eye. The other sensor is going to determine the point that we want to focus on, or the focus point. Okay, now these two sensors are going to provide us with the information that we need. We need to process this information. So what we need a microprocessor or a microcontroller. For those of you who don't know what a microprocessor or microcontroller is, this is a microcontroller. It's an integrated circuit or an IC. It has the ability to control things, so we can program the chip and tell it what to do, what not to do. We can do whatever we want by giving information, programming these chips to employ them and utilize them and for this things that we want to use it for. Alright, so the microprocessor is going to receive the information from the sensors, and then after the information received from the sensor, the microprocessor is going to process this information. After the information is processed, we're going to have an output. The microprocessor is going to produce an output signal, and this output signal is going to be received by the lens. And this output signal is going to control the lens, whether it's moved to left and right, whether it moves up and down, or circular directions, horizontal, vertical, whatever direction it is possible for the lens to move with respect to the position of the eye. So this is how we can control the lens.
So, as can be seen, sensor 1 detects the eye position, sensor 2 detects the point that we want to focus on, and these two information are going to go into the microprocessor. The processor is going to process these information, and with respect to this information, it's going to produce a signal that has the ability to tell the lens to move in the direction that it has to. This is how it compensates for the eye movement.
Okay, another thing that I want to point out is the material that the lens is made of. It could be glass, it could be plastic, it could be even a liquid like water. Did you know that we could make a magnifier or a lens out of water? Yes, we could do it. So moving the water is going to be much easier than moving a lens made out of glass. So if we can place the water in between two surfaces, for example, two surfaces of very, very thin glasses, then we could move the water in between the glasses like this. And it's just like moving the lens. It plays the role of the lens made of glass. Yes. Okay. So now that I explained how the device works, and you got all the information required, we really need to know how we can make such a device and solve thousands of problems for thousands of people all over the world having nystagmus. But you know, creating such a device is something that has to be done under the support of an organization or a corporation. Therefore, an individual like me cannot do it without support. But I really hope one day comes that we can create this device and solve many problems for many people having nystagmus. Okay, thank you very much for watching this video, and if you want to contact me, you can use the email in the description, or you can contact me in the Facebook provided in the description with the name Ehsan Arefi. Thank you very much for watching this video. I really wish the best things for all the people having nystagmus all over the world. Thanks again.